Good afternoon, everyone. Good to see you all, even though many of you are very, very far away at the opposite ends of the room. My name's Tim. As you might be able to tell from my accent, I'm from London in the rainy United Kingdom. And I'm a software engineer at a fintech startup called Go Cardless. To give you some context before I start trying to claim that I have knowledge or expertise about APIs, let me tell you a bit more about what we do at Go Cardless so you can see where my knowledge comes from. So at Go Cardless, we're building an API-driven bank-to-bank payments network for the internet. What does that mean? Well, we're all familiar with the big we're all familiar with the big credit and debit card networks. So Visa, MasterCard, and American Express. Well, alongside those, there's an alternative, the bank-to-bank payment networks. The credit and debit card system has a lot of intermediaries. There's lots of people on the way from your account to where the money's going who are taking a cut. On the other hand, there are these bank-to-bank payment networks, which involve taking money straight from one account and dropping it in another with no intermediaries. Most of these systems are country-specific. So, for example, direct debit in the UK or bank giro in Sweden, although the Eurozone actually has a kind of unified system for all countries that use the euro. So the problem with this is it means that if you're a business that wants to collect payments in multiple places, that becomes very difficult because these schemes are different in every place, so you have to do a different integration with different banks, things like that. The aim of Go Cardless is to build a single network that covers all of these countries' systems. APIs are at the heart of our business, as that's the way that people interact with this. We build one API that lets you take payments wherever you are. Building APIs brings some particular challenges from a software engineering point of view, especially when users are relying on your API to run their business. So at Go Cardless, we've built up a lot of experience around designing and implementing great APIs, since they're at the core of what we do. So today I'm going to talk a bit about building APIs with Rails. Now, it's important to note that building an API with Rails isn't as simple as just turning on API mode in your Rails application. There's a lot more to it. What I'm going to talk about today isn't a kind of secret or weird trick, but rather I'm going to be talking about how to apply the lessons of software engineering to help you make your APIs more maintainable. In particular, I'm going to talk about a pattern called the Middleware pattern, which is based on these principles and helps you to write better, more maintainable code. So when I say maintainable, what do I mean? I mean that we want our code to be understandable, testable, reusable, and adaptable. Let's just go into each of those quickly. So firstly, we want our code to be understandable. We want code that we, or another member of our team, can come back to in a year's time or more and actually understand what it does. We want code that's testable. It should be written in such a way that we can easily cover the edge cases, and then we can be confident as we use our code and as we make changes to it. Thirdly, we want our code to be reusable. We want to have a consistent interface in our API, for example, having authentication work in the same way everywhere. When we want to make changes to our API, we don't want to have to change 100 places. We want to have one place that covers everything. And finally, we want our code to be adaptable. It should be able to evolve over time, rather than being resistant to change. In this talk, though, we're going to focus on making APIs understandable, testable, and reusable using the middleware pattern. Let's get started by building a simple API using ActionController. That will help us to understand the maintainability challenges we face and the problems that we're actually trying to solve. We'll then think about how we can refactor our code to make it more maintainable. This talk is going to be quite heavy on code, and unapologetically so, but I'm going to go through it slowly and highlight the bits that are relevant. That way you can actually get to understand what the point is and what we're trying to achieve here. So we'll start with it by imagining a really, really simple API. It creates a customer based on their email address and their bank details. So what would we do if we were building that using Rails? We'd probably start off by making a customer's controller that inherits from ApplicationController. We'd then start by defining a create method, a create controller action. It builds the customer from the incoming parameters and then tries to save it. If everything goes well, then we render the customer back as JSON. And if there's a problem, then we'll render back validation errors so the user knows what went wrong. This is all quite simple so far, right? We aren't seeing the problems here and the complexity. But we're missing a lot of important components of our API here. For example, our API would need some kind of authentication. The standard way to do that is to pass an access token in the authorization header, like this. So how are we going to handle that header? One option would be to add this code straight to our create method But that immediately makes our code a lot less maintainable. Firstly, our code is harder to understand. Straight away, we've got a long method doing lots of jobs with no division of labour. It's also less reusable. That authentication logic isn't abstracted out, it just lives in the method and it's kind of stuck in there. And thirdly, our code is hard to test. We can't exercise the authentication logic on its own. We can only exercise it in the context of creating a customer. The most common solution to this problem in the world of Rails is to split out things like authentication using Rails' filter functionality. So for example, we could define a method called checkAuthorizationHeader, and then we can tell Rails to run it before our controller action by using beforeAction. Filters let you run code before, after, or around your controller action. So we define a before filter, and that will be run before our controller action. So for example, here in our checkAuthorizationHeader method, we pull out the value of the authorization header. If the header is missing, then we return an error. This is an important part of how filters work. If you raise an exception or return an HTTP response, then your code essentially stops execution. You don't continue on through the filters, and you don't actually hit your controller action. So once we've checked that the header has actually been provided, the next step is to check that it's valid. So if you remember, the authorization header has two parts. It starts with bearer, and then there's a space, and then the access token. So we just write some simple Ruby code to split that in two, and then we check whether the token starts with bearer, and return an error if it doesn't. If everything looks good, then we save the access token to an instance variable, because we want to, in a later filter, be able to use that to actually check if the access token exists. So now, having extracted the access token, we actually check whether it exists. So we add another filter, check access token. In there, we look up the access token from the instance variable and check whether it exists. If it does, we save that user into an instance variable, which we'll then use in the controller action. If there's any problem, so the access token doesn't actually exist, then we return an error. Otherwise, we've reached the end of our filters, and Rails will pass over to our controller action. So now in the controller action, we can make use of that @user variable that we've stored. There are tons of other things that we might want to add to our API that are a bit like this, that we'd probably do using filters. For example, we might want to validate the input against an API schema. We might want to record statistics about who's using which APIs, or we might want to enforce users' permissions. For now, we'll just take a look at one more real-world example from Go Cardless: internationalization. So let's say we want to return our errors in the language of the user. There's a standard header in HTTP called accept language, where you can specify the language you want the response to be in. So here we set accept language to UK-UA, saying I want to have the response in Ukrainian. So then we add an around action, so an around filter, which sets code to run around our controller action. And in there, we use Rails' built-in internationalization functionality to use the language specified in the request. And having done that, we can continue on by calling yield. That will then move on to the next filter and eventually to the controller action. Very quickly, this approach of adding more and more filters gets out of control and leads us to a world of pain and unmaintainability. Here's a real-world example from a controller at Go Cardless that used to power our OAuth flow. You ended up with no less than 12 filters in the worst case. Our code gets really painful really quickly, and particularly the instance variables really bite you. You end up, every time you want to make a change to the controller, having to scroll through hundreds of lines of code trying to understand where the data comes from and how it got there, so you can debug problems. So what happened here? Why does our code get out of control so quickly? Where do all these filters come from? So the create method in our controller, the controller action, contains what you might call endpoint-specific logic. You don't need to reuse it. It's just a one-off task that you use in one API endpoint, creating a customer from the incoming parameters. This code tends to stay fairly simple, and where it doesn't, as we've already heard from other speakers today, there are good solutions in software engineering to help us with that. So for example, we could move the code from the controller to a service object. It's pretty simple. Things get a lot more complicated though when you've got this reusable logic that you want to use across your API. This tends to happen a lot with APIs because you're trying to provide a consistent interface to your users. So you want all your API endpoints to work in roughly the same way. So you end up wanting to have lots of filters to do different things, from authentication to validation to internationalization. So what's the problem here? Even just by adding a few of these filters, we've hit 3 problems. And we've got a 4th problem, which is that emojis don't work very well on Windows. And these problems make our application less maintainable. Our code's hard to understand, particularly in the way that it uses state. So I've already talked a little bit about instance variables. We naturally want to split our logic into different methods to make our code as clear as possible. So for example, we split passing the access token from the header from checking if it's actually valid. But then the problem is that we need to share data between those steps. And we also need to share data from the filters with the controller. So in the case we've been looking at, you want to take the user that's authenticated and have that accessible in the controller action. Using this kind of instance variables approach makes that quite difficult. The state's hard to reason about. There aren't clear dependencies, and you have to scroll through your files to understand where it's coming from. Secondly, our code lives in our controller, so it's difficult to share it, reuse it, and adapt it. We'll just end up duplicating it when we want to add another API. For example, an API to collect a payment from a customer. And thirdly, our code is hard to test. We want to be able to test all the edge cases in our logic. For example, what happens if there's no authorization header? What happens if a user specifies a language that we don't support? We want to be able to test the response that's sent to the user and any state that's constructed. Doing that here is quite difficult because you can only test it within the context of this specific controller. The solid principles are a series of software engineering design principles which help us to make our code more maintainable. One of these principles is the single responsibility principle, which is at the heart of the middleware pattern and is part of what makes it brilliant, I think. This single responsibility principle helps to make our code more understandable, reusable, and testable. So what is this principle? I'm sure many of you will be familiar with it, but it's useful to recap for people who might not have heard of it. So the single responsibility principle says that every module or class should have responsibility over a single part of the functionality provided by the software. And that responsibility should be entirely encapsulated by the class. In short, what we really want to do is turn each of our filters into a single class with a single responsibility that covers an entire area of our logic. That makes our code more maintainable. So before we dive into middleware and run away from the Rails way of doing things, it's worth understanding whether there's a good Rails solution to this problem that's kind of built in. So far, we've been using filters defined in our controller. And that's certainly better than adding the reusable logic to each controller action. But as we've seen, there are still some maintainability challenges. The Rails documentation offers a few options for kind of separating out filters and making them more maintainable. The first is to move the filters away from your concrete controller and move it into the superclass. So usually that would mean moving it to ApplicationController. So we can move our methods to ApplicationController, and then we can either call before action in ApplicationController, if we're really sure we want to use those filters absolutely everywhere, or if we're less sure, we can define the methods in the superclass and use before action in the subclass. Our second option is to move the filter methods to their own modules and then include those modules into our controller. This is the standard Ruby way of sharing code between classes. We create a separate module. So here we have our module API authorization header. And then in that module, we define the method that we want to share. Then we can include that module in our controller, and it will behave just like the check authorization header method was defined in there. So we can just use before action as we were before. If we want to be extra clever, we can use a little-known bit of Rails called active support concerns, which lets you add the filter automatically when you include the module. All you have to do is extend the filter with active support concern, and then when you include it, if you add this included block, you can make it do the before action for you. So now we've separated our logic into its own class, but it's still not that easy to test. There's a third option which makes this a little bit better, and that's to use a filter module. This gets us a bit closer, with the logic separated out and a more testable interface. We start by defining a module. So again, here we've got our module called API authorization header. And on that, we define a before method, which gets passed a controller. We could do the same thing with an after filter or an around filter by calling the method the obvious name. Having access to the controller means that we can do everything that we could do when our filter was inside the controller itself. So for example, we can see the request looking at its headers. We can render by using the controller's render method. And we can even store state by adding an attribute writer to the controller and then referring to it from the filter. We use this filter class by passing in its name to before action. So now our filter is abstracted out and fairly simple to test, since we can pass it a fake controller and see what happens. So for example, what gets returned and what state is stored. But using instance variables for state still leaves things being quite confusing, I think. And testing using a fake controller just leads to quite ugly tests, and it's not that nice to use. So I don't feel like the Rails way really gets us to where we want to be. We haven't found a good solution. So let's see how the middleware pattern can help us. It can help us to get to more easy to understand, easy to test, and easy to reuse code. So what is it? Surprisingly, Microsoft's ASP.NET documentation actually has the best definition I could find of the middleware pattern. It says that middleware is software that's assembled into an application pipeline to handle requests and responses. So what we do is we chain together a bunch of middleware into a pipeline. There's a kind of division of labor, and then those middleware work together to handle the request and return a response. Each middleware in the pipeline can do two key things. Firstly, it can choose whether to pass the request onto the next middleware in the pipeline. So it can basically do two things. It can either return a result itself, or it can delegate onto the next middleware. So for example, if we turned our code which checked the authorization header into a middleware, it might return early if the access token isn't valid, or if it is valid, then it will pass on to the next middleware in the pipeline. A middleware can also perform work before and after the next middleware in the pipeline is invoked. So for example, we can fetch some data and pass it into the next middleware, or we can even run something after the next middleware, for example, do some logging. The middleware pattern has been particularly popularized by frameworks like Eclipse, like Express in JavaScript, as well as in a variety of other languages and frameworks, for example, Elixir's Phoenix. So what's so great about this pattern? Why is it that moving towards a pipeline of middleware helps us to make our code more maintainable? At the heart of this is the single responsibility principle. Instead of big, unwieldy pieces of code doing many things, we can get to a world where we have simple classes that each do a single job. This makes our code more maintainable. It's easy to understand because each middleware does one simple thing. We then assemble those middlewares into a pipeline, and they can work together to do complex work. Our code's more easy to reuse because the middleware have one job and you can assemble them together. And you can even make them configurable. And finally, our middleware are testable. You can call the middleware on its own outside of a controller, pass in some input, and see what happens. Particularly, you can see if a response is returned or if the next middleware gets called. Now, as many of you will know, hidden from view, middleware are actually at the heart of how Rails work. Rails is built on Rack, a Ruby framework for building simple, modular web applications. Before the code you've written gets run, or even before the core of Rails gets run, a bunch of middleware get things ready. One example of this is a middleware called ActionDispatch Request ID that's part of Rails, which runs by default with every request. If you ever looked in detail at the responses from your Rails application, you might have noticed that there's a response header called xRequestID. Well, that's added by this middleware. On the screen, you can see a simplified version of it. So, it can see the incoming request, which is represented by this env variable. It generates a request ID at random, and then stores it as part of the state of that request, so it can be used later by other middleware in the pipeline, or even by your code. Then, it calls the next middleware in the pipeline. But the interesting thing here is that it doesn't stop then. After the next middleware in the pipeline and eventually your application has been run, it then changes the headers of your response, adding the xRequestID to the header. Rack middleware do roughly what we want, but unfortunately Rails doesn't make it very easy for us to use them. You can't plug Rack middleware in on a request-by-request basis. Instead, you have to set them up in config/application.rb. This isn't so good because we really want to have more flexibility in the way that we use our middleware. We want to be able to decide what ones to use in each controller and for each action. So let's see how we can refactor our API using middleware, making it miles more maintainable. To do that, I've written a simple implementation of the middleware pattern for this talk in about 25 lines of code. We'll go through it now, and then we'll do the refactoring. I call it simple middleware. You can find the code on GitHub, but we'll go through it together now. So first, let's look at the interface of this middleware library. This is what our controller is going to end up looking like. We call simple middleware, and we pass in a list of middleware we want to run through. And then we also specify the data that we want to pass into those middleware. So here, we want the middleware to have access to the request, so it can look at the headers. And we want the middleware to have access to the parameters, so we can see the user's input. We've turned our 3 filters from earlier into a middleware. We've also defined a final middleware here called create. In there, we'll put the endpoint-specific logic. So we could do this bit a bit differently. It's possible to keep that logic inside the controller action, just rely on the result of the middleware. But I think it's a bit nicer and more consistent and easy to test to even turn the controller-specific logic, this endpoint-specific logic, into a middleware. It's also easier to unit test that way. At the end of the middleware chain, we expect to get back a rack response, which, as you might have seen if you've gone into rack at all, is an array with a status code, some response headers, and a response body. We'll have this same kind of response, whether there's an error in one of the earlier middlewares, or whether we actually create the customer successfully and then want to return it to the user. So, we've seen what the interface of this simple middleware library looks like. Let's have a look now at how it works. So we've already talked about how a middleware can do basically two things. It can either return a response, or it can call the next middleware in the pipeline. Well, here we have access in the class to the next middleware. We pass it in and have an attribute reader so you can call it. It's then up to each middleware to define a call method which actually does the work. This method can use the state that's passed into it, and then it has two options. It can return a response, or it can call the next middleware, passing in the state, and it might even change the state on the way, so for example, adding something to it. Thinking back to our example, we put together a pipeline of 4 middlewares. Each middleware can perform a single job, and together they handle the request and response. Our pipeline gets run through in exactly the order we specify it. This is important as some of our middleware will end up depending on other ones. For example, our access token middleware needs to have access to the access token that's come from the header, so it depends on the authorization header middleware having been run first. So the code to put together our pipeline of middlewares is actually very simple. It takes the list of middleware that are passed in, and then stacks them into a pipeline where all each middleware needs to know is what the next one is in the pipeline after it. Once we've built the chain, we then call the call method on the first one, passing in our initial state. That state can then cascade down through the pipeline. For the state here, I'm using an immutable hash provided by the gem immutable Ruby. An immutable hash can't be mutated, that is, it can't be changed. This means that all the operations you perform on them actually return a copy of the object with the change you've made. Using this kind of immutable API can give you more confidence in the code that you're writing and means that you won't accidentally mutate things. So let's go through what happens when we call our pipeline of middleware. First, the locale middleware gets called. It sets the locale and then calls the next middleware. It knows what the next middleware is. It's the authorization header one. So now we're in there. This middleware might return an error. For example, if there's no authorization header, in which case our pipeline stops and we don't continue onwards. Otherwise, we call the next middleware, giving it access to the access token that we've just extracted. So now we check that access token. If it doesn't exist, then we return an error. If it does exist, then we take the user we've just found and pass it on to the next middleware in the chain, which is our endpoint-specific action. That can then kind of create the customer, save it, and then return the final response to the customer. That's how simple middleware works. As you can see, it's pretty simple and there's very little code. You'll find the full source on GitHub. Now it's time to do what we've all been waiting for, refactoring the API we built at the beginning using middleware. We'll write our new middleware plus unit tests. You'll be able to download the code for this as well at the end if you want to, so don't worry about following along too closely. So let's think back to our original controller from the beginning. We had 3 filters, with locale, check authorization header, and check access token. We want to refactor those into 3 middleware, using simple middleware. We also then want to rewrite the create method, the controller action as a middleware as well, and that will go at the end of the pipeline. Any specs we've already written for our controller can really help us out here. They can act as integration tests as we move from using ActionController for everything to the middleware pattern. They can help us to test the edge cases and give us confidence as we make changes. We'd expect them still to pass after we've done our refactor. As an example, I've already written some tests for this example controller that we wrote, which you can find in the GitHub project, but I won't show you them here. So we're going to skip the with locale filter because it's not very interesting, and go straight to the check authorization header filter. Let's turn that into a middleware together. So the fundamentals of our middleware are simple. We have a class that inherits from simple middleware and defines a call method, which expects to be passed the current state. The call method can access the next middleware in the chain, and then it can either call that or return a response itself. Thinking back to the controller, as part of the initial state, we passed in the request and the parameters that the user supplied. The request exposes the HTTP headers, which we need to have access to get the value of the authorization header. So we look at the request in the state and then pull out the header. Now we check the header with exactly the same code as we had before, and we can return an error if that header doesn't look right. Simple middleware also defines a render method. It's just a simple helper that returns a rack response, so that array of a status code, response headers, and a body. Having the render method just gives you a slightly nicer API for doing that, but you could just return the array yourself if you wanted to. In our controller, we take that response and then render it back to the user. So what about the case where there's an access token in the header, so we don't need to respond with an error? We want to take that access token and pass it on to the next middleware in the chain that will be responsible for checking if the access token exists. To do that, we build the new state by calling the put method on our immutable hash. That then returns a new version of it with the access token added. Then finally, we can call the next middleware with that new state. So the state now looks like this. We've got the request and the parameters from before, but also now we've added the access token to that, which the next middleware will have access to. The beauty of the middleware pattern is that we can write really simple unit tests, passing in the initial state and a fake next middleware, and then we can check what is returned or whether the next middleware in the chain gets called. So we can really test that very specific piece of functionality really easily. So let's have a look at how we do that. First, we'll look at the setup for the test. So the subject of our test is an instance of the middleware. As we've already seen, when you instantiate the middleware, you pass in the next middleware in the chain. For that, we'll just use a kind of fake middleware. It's an RSpec double that has a call method that just returns true. In our tests, we can check whether or not the middleware calls the next one by using an RSpec message expectation on that next middleware. We'll see that in a couple of seconds. Our initial state is just a fake Rails request. The middleware refers to this request in order to grab the authorization header. So you might remember in our controller that we passed in both the request and the parameters. We won't do that here, as the middleware doesn't actually need the parameters, and we might as well pass in the bare minimum state that we need to test this. So let's write our first example, the case when there's no authorization header. We pass in the initial state, so that's a request without an authorization header, and then we check what's returned. So we check that we've got that rack response that we expect, a 401 unauthorized error with the correct body. The case where the header isn't structured correctly, so say it started with foo instead of bearer, is very similar. We pass in some state. This time we've got the wrongly formatted header, and then we check that the right error is returned at the end. The final case we need to test is where the authorization header is present and valid. In that case, we want to make sure that the next middleware in the chain is called, so we pass on to that. And we want to make sure that the state has the access token added to it. So we use an RSpec message expectation here. We say that the next middleware should have received the call method, and it should be passed the request plus the access token that's been added. We don't expect anything to be returned. That's the job of the next middleware in the chain. So now let's go through the next middleware, the access token one. We'll go through this one a bit more quickly, since we've already seen an example. We pull out the access token from the state, and then we try to find a user with a matching access token. If there's a match, we call the next middleware, passing on the authenticated user. If there isn't a match, then we return an error. The specs from this second middleware look pretty much the same as the last one. We'll start with the SAD path, giving a non-existent access token and checking that the right error is returned. So here we pass in dummy access token, and we check that we get a 401 back. And then we'll test the case where the access token is valid. Again, there we expect the next middleware to be called and to have the user added into the state that's passed to it. We're going to skip, as I said, the locale middleware for now, and we're going to move straight on to rewriting our endpoint-specific code, so the create middleware. Here, we want to build a customer, try to save it, and then either render back the created customer or return an error. We use the state to build the customer attributes. So what does that look like? So if you remember, at this point in the state, we have three things. We now have the parameters, the request, the user, actually a fourth, the access token as well. All we need here is the parameters and the user. So we pull out the email and the IBAN from the parameters, and then we merge in the user from the state. That means that the customer we create will belong to that user. Having built the customer, we then try to save it. And if that's successful, then we render back the created customer. Or if there's a problem, we can render back the validation errors. If everything has gone to plan and we haven't made any mistakes, our controller specs will still pass. So we've just successfully refactored our Rails API using middlewares. We've made it a lot more maintainable with this implementation of the single responsibility principle. As a reminder, the simple application we've just built is on GitHub. You can find it at github.com/timrogers/simple middleware example. So we've seen how to make our APIs more maintainable using middleware. I'm convinced that this pattern makes your code much more maintainable and makes your API more of a delight to work with. But I wouldn't actually use simple middleware. I only built it for this talk. With a more fully featured middleware library, we can make our APIs even more maintainable and have a much better developer experience. But using a simple implementation like this helps us to understand the core principles of the middleware pattern without getting distracted by complicated features or magic. At GoCardless, we built a library called Coach, which is a more fully featured implementation of this pattern. I'll take you through a few of its features that really help to make life as a developer really great. Firstly, with Coach, a middleware can depend on other middleware. This makes it much easier to build your pipeline. For example, here we define the endpoint-specific code as a middleware, which we call routes customers create. We then say that that middleware depends on the 3 other middleware. At GoCardless, we tend to refer to this endpoint-specific middleware as a route, but really it's just a middleware. Making it work this way, with a middleware knowing what its dependencies are, means that we can actually plug our middleware straight into the Rails router, completely skipping ActionController. We still love Rails, especially for the active model and using Ruby in general, but we find that for APIs at least, the middleware pattern works better than using ActionController and its filters. Middlewares can even be configured using Coach, making them more adaptable and reusable. When we depend on a middleware by calling the uses method, we can pass in configuration, which we can then refer to in the call method. So for example, here we say that what the required permissions are, and we can check that in the middleware. A middleware can also define exactly what data it provides and what data it requires, the data it has to have and the data that it will give to the next middleware. This makes your code easier to follow. Here, for example, in the access token middleware, we say that at the end of it, it's going to provide a user to the next middleware in the pipeline. And in the route, we say that it needs to have a user to do its work. This gives us a really cool feature, which is a bit like static analysis. When our application boots, it can check all of our middlewares and check that their dependencies are fully satisfied. So for example, if I declared that the route needed to have a user, but I didn't have a middleware in the dependencies that provided it, then the application can error at boot, so I don't accidentally deploy code that doesn't work. Finally, Coach provides some really nice unit test helpers. This makes it easy to unit test your middleware in an elegant way that is declarative rather than long and repetitive. You can find Coach on GitHub at github.com/gocardless.coach/coach. There's also a blog post there that takes you through it and an example application. So, to recap, we want our code to be as maintainable as possible. That is to say, we want it to be understandable, testable, and reusable. But as we've seen, controller filters quickly get out of control. We've seen with a real example how they can lead to unmaintainable code. But the single responsibility principle points us in the right direction, towards simple classes that do one thing. The middleware pattern is an implementation of the single responsibility principle, and it helps us build better APIs. Using Coach, you can hit the ground running with the middleware pattern, much faster than you could with something like simple middleware, and you can have a really great developer experience as well. If you like what you've heard today, thanks so much. Thank you for coming. I hope this talk has been interesting and useful. You'll be able to find all the slides for this talk on my website if you want to read through again. That will be at timrogers.co.uk, and then just click on speaking. Otherwise, I'd love to hear what you think, and I'll be here for the rest of today and tomorrow. Or you can tweet me. I'm at Tim Rogers. Thanks very much.
Thank you, Tim.